So, good morning to all. Today we will talk about artificial neural network. This is very important topic. We already learned few classification technique. So, this is also a different style of classification technique. So, courtesy for this slide to that Bipin Kumar book. So, directly I have taken the slide from the Bipin Kumar. So, first we will start talking about what is a neuron, because we are talking about neural network and so on. So, a basic idea of artificial neural network is a complex nonlinear function that can be learned as a composition of simple processing unit. So, therefore, actually artificial neural network is nothing but it has several number of huge number of simple processing unit. So, to understand the entire structure, what we need to do, we should know the simple processing unit. So, N is a collection of simple processing unit and they are interconnected by the direct link. So, every node receives signal from incoming edge, perform computation and transmits the signal for the outgoing edge. That means, so simple processing unit, it perform simple operation and then it transmit the information to the other nodes. So, therefore, now we will focus what the simple processing unit actually does. And because the name the artificial neural network, so we have the analogy to the human brain, where the nodes are represented by the nodes and signals are the electrical impulse. So, weight of an edge determine the strength of the connection between the node. So, simplest artificial neural network is perceptron. That means, how the one simple processing unit computes the other operations that we will see using simply single neuron. Okay. So, here, so this picture is really we should focus here. So, what we got it here, say suppose we have a simple processing unit is here, and as I said just beginning of this class, it should have some link between the other nodes. So, we have a few nodes here, few nodes here, and then we have a link here, we have a link here and here. So, what we have, for each link we will have some weight. So, let us say W1, W2 and W3. So, essentially what that processing unit does, it perform two operation, one is summation, another is the sign function. Summation is basically it is summing the weighted sum of the input values as x1, x2 and x3. Okay. And then for the time being you just consider there is no part here, there is no part here. Okay. Now, essentially what it does, it basically compute the summation, that means it compute x1 W1 plus x2 W2 plus x3 W3. Okay. And after that there is a term is called B, it will be added plus B, and if this value is greater than equal to 0 or no or not, so that depends on another processing part is there. So, that is a sign function. If this value is greater than 0, it will convert to 1, and if it is lesser than equal to 0, it will convert to minus 1. So, that is the processing unit. What processing unit does? Processing unit is doing computation, that means summing up, and then another is the sign unit. So, sign unit basically sign unit it is doing the converting that one into either plus 1 or minus 1. Okay. So, now we will learn what is this, okay, why it is written like that. See x1, x2, x3, these are the column vector. So, that is why I written x1, x2. So, that is x1, x2 and x3. So, instead of writing B here, what we can do it, we can write. So, here now we can use the term here. So, now what we can do it, say we can consider there is a link here and that input is always 1 and that weight is W0. So, therefore, what will be there? So, instead of W0 we wrote it B, okay, we can write see here B. Okay. So, now our input vector will be, so column vector will be 1 for this one, then x 1, x 2, x 3. So, that is x 1, x 2, x 3. What is W t? W t transpose W weight is also a vector. So, weight is W 1, W b, W 1, W 2, W 3. Okay. So, either b you write at the beginning or end, it does not matter, it value remains same. Okay. Now, W transpose t. So, now if you make it transpose, so it will be like that, and then x is a column vector. So, x is 1, x 1, x 2, x 3. Now, what you do? You multiply. So, this is a matrix multiplication. This size is 1 cross 1, 2, 3, 4, and this is 1, and this is what will be the value of it? This will be 4 cross 1. Okay. So, B is included here as we see. Now, if this value is greater than 0, okay, if this value is greater than 0, so if this value is greater than 0, then we will say ki positive class, otherwise it is negative class. Same thing is written here, that is actually this is right, but if you write like that, if you write like that, so that indicate like here. So, B we added whatever the B value, so we added B, so that we got this part, and now we whatever the value of x t we got it here, and then this is sign value is nothing but it will make the value either 1 or minus 1. If it is this value, if this value after doing this operation, if this one is greater than equal to 0 or greater than 0, then it will be plus 1, otherwise it will be less than 1. So, here what we got it, basic idea is that a simple processing unit is doing only the summation, and then it is converting to the another either 0 or 1, or say it is plus 1 or minus 1. Okay. So, now one example here is a more concrete example. Suppose we will assume we have a black box and we are giving the input x 1, x 2 and x 3. At the end of the day, what we should get output. Now, within the black box, what is there? Within the black box we have a single perceptron, that means we have a processing unit and we have a connection from here to here, here to here, and what to here to here, and then obviously the weight say W 1, W 2, W 3, and obviously we have the B. Okay. So, that is there inside the black box. Okay. So, here we go. So, we have this one x 1, x 2, and then here t is actually minus t is minus 0.4, not this one. Now, what is that? Once we get these weights, then simple equation is W 1 into x 1, W 2 into x 2, W 3 into x 3, and then this is minus 0.4 plus B. Okay. Now, what you do it? See, any value you take, let us say this one. So, x 1 is 1, this is 1, x 0.03 is also 1, and this is 0. Then what will happen? So, 0.3 into 1 plus 0.3 into 1. So, this is 0.6, okay, minus 0.4. Okay. So, this is 0.6 minus 0.4. So, this will give you 0.2. So, that is greater than 0. So, therefore, output should be 1. For this case, output should be 1, and that is we see output is 1. Okay. So, we will explore this part in more details. So, here how to assign the weight. We will get the single perceptron, that is fine, but how do you set the weights? So, here we go. So, we initialize any weights, that is any value for W 0, W 1, W t. So, W 0 is nothing but here B. Okay. So, now what you do it for each training sample, that is earlier we saw the training sample. What you do? First you compute YR bar. What is YR cap? YR cap is nothing but the predicted value. So, YR cap is nothing but W 0 plus 1, that is plus W 1 x 1 plus W 2 x 2 plus W 3 x 3. So, first we compute this one. Now, what we have to do? We have to update the all variable, that is all parameter, that is weights W 1, W 0, W 2 and W 3. For any values of weight, what you do, this is the formula we can apply. What is the significance of this formula? So, whatever the old value we take it and then we multiply with the value lambda. So, lambda is something called learning parameter that we may learn later on. Let us say it is a small value 0.001 or something like that, and this term, what is this term? This term is nothing but the error. This is we predicted, okay, and this is the original value for the training sample, because each training sample should have the y. So, this is nothing but this part. Now, what do you do if whatever I predicted or machine predicted is same as the actual value, then obviously this part will be 0. So, there is no need for updating this one, because all old value will be updated. Now, if there is a error, so therefore, this part will get some value here, because this is positive and this part will get some value, and this is this value is let us say 0.001. Now, if this value let us say y I is positive and y I is negative, so that is also wrong, because what we say is we should have value plus 1 or minus 1. Now, if you see the actual y I value is positive, that is 1, and y I bar after computing this one we are getting value negative, because y I is not only this one, we have a sine function, that is SIG. So, whatever the value, if it is greater than 0, so that will make it 1, if it is less than equal to 0, so that will make it minus 1. So, if value let us say if less than equal to 0, then it will make minus 1. So, then this is minus and another minus 1. So, this value itself will give you the 2, that means error is 2. Now, what happened? That means actually I should get 1, but my system is giving minus 1. So, therefore, that weight should be improved, weight should be up, then only we can match it. So, therefore, we should put Wij plus whatever the old value, that should be updated with this value, and obviously this is the input for the ith training sample and jth feature. So, I think I will show you one more example, then it will be much more clear here. So, now this is the error. If error is 0, that means it is exactly the I predicted or system predicted and actual. If both are same, so there is no need for update, that is I said here. Now, if error is 2, that means system is predicted minus 1 and then actual is 1. So, therefore, it has to improve. So, that means whatever weight is there, it should be updated. So, therefore, weight must be increased. Now, it reverse way around. So, if this y I is minus and then y I cap I computed plus 1, then what happened? This is plus 1 and then outside minus, so it will be minus 2. That means, it is predicting more than actual. So, therefore, the weight should be decreased. So, therefore, if E is negative, the weight should be decreased. Now, it will be much more clear in the next example here. What is that formula? Formula is that we have to update here. Now, what are the weights? We have the weight W0, that is for bias, then W1, W2, W3, right, and then we have the value x1, x2, x3, and then we have also value is something called x0, and which is 1 for the all sample. Okay. Okay. So, now what do you do it? I want to update the value for, and I want to get the value W0, W1, W2 and W3 using the previously I told, not even though here it is also here. Now, first we consider that all weights are 0, that is W0, W1, W2, W3 all are 0. Okay. So, now I got the first training sample, initial values are, let us say initial values are 0, and now I got the training sample here. So, what is the training sample? x1 1, x2 2, x2 0, x3 0 and actual value is minus 1. Obviously, you should have a value x0 is also 1, this is always 1. Now, what is the first task? First task you have to compute this y bar. What is y bar? Y cap. So, y cap for the sample ith sample, because this is ith sample and number of iteration, let us say first iteration. So, then what do you get this value? So, value will be x0 which is actually 1 into W0 plus x2 into what is that? x2 into x1 into W1, x2 into W2 x 3 into W 3. Now, what is that value? All W 1, W 0 all are 0. So, therefore, y I cap sine of 0. Now, sine value what we do it? If it is greater than equal to 0, we consider plus 1. If it is less than equal to 0, less than 0, then we will consider minus 1. So, therefore, sine of 0, it is greater than equal to 0. So, that will give 1. Okay. So, now we computed y k bar. So, what about y I? Y I is minus 1. So, then what value will got it? Minus 1 and this is 1. So, this is minus 1. Okay. Therefore, we will show the how the weights are updated. So, we started with all zeros. So, what I said ki first you have to compute this part. Okay. So, what is this part? As I said, this will be W 0 1 plus W 1 x 1 plus W 2 x 2 plus W 3 x 3 and then you give sign. So, that is nothing but y bar, y cap. Now, what is the formula? If it is greater than equal to 0, so that will be plus 1, otherwise it is minus 1. Okay. Now, all values are 0, like this is 0, this is 0, this is 0, this is 0. So, sine of 0, sine of 0 what will come? Sine of 0, sine of 0 is nothing but the plus 1. So, this will be plus 1. Now, what is the original value? As you can see, original value is minus 1. So, therefore, this one will be minus 1 minus of this value plus 1. Okay. So, then this part will give you minus 2. Okay. Okay. So, this part will give you minus 2. Now, what will happen? This value is minus 2 and then what is this value? This value is x I j. Now, we have to see for which weight we want to update. Let us say W 0, W 0 is responsible for the bias. Okay. So, therefore, what we write it? This is W 0 and say this is for first iteration, this will be W 0. What is the value of W 0? W 0 is 0. So, 0 plus learning rate value is 0.1. So, this will be 0.1 into minus 2. Okay. Minus 2 into what is this value? This value will be 1 because for W 0 always 1, W 0 is multiplied with 1. So, now what value will get it? So, this will be 0 plus 0.1 into minus 1. So, this will give you 0.2 and obviously, this will be minus okay, and this value will be 1. So, ultimately W 0 will get the value minus 0.2. So, therefore, this W 0 value is coming 0.2. Now, what happened to value W 1? So, now again we have to compute W 1 new value, that is W 1 old value, that is 0, 0 plus 0.1, that is learning rate, that is here, into that error. What is the error for this sample? This error is minus 2 and x I j, x I is the first sample and j means what is? J is the first feature, that is x 1. What is the value of x 1? That is 1. So, this will be 1. So, therefore, this will be also minus 0.2 and that is we see here. And what happened for the W 2? Let us say if you compute for W 2, W 2 old value is 0, that is as you can see, and then what is that formula? Formula is here, that is 0.1 into error, error is minus 2 and then x I j, that means first sample, but jth feature, jth feature means second feature here is 0. So, then you multiply with 0. So, therefore, W 2 will be 0 and that is we see W 2 is also 0. Similarly, what we see is W 3 also will be 0. Okay. So, now if you compute for the second sample, let us say arbitrarily we compute for this sample. Obviously, if you go for this sample, previous weight whatever that. So, this is 1, 2, 3, 4. So, we have to consider we have this weight right now. Now, again we compute the all values. Let us do this one for the fourth sample, that is 1 1 1, output is 1, and then we will get this weight. Earlier fetch the whatever the weight that we need to consider. Okay. Okay. So, what we will do is current weight we consider this one. What is that? W 0 is 0, W 1 is also 0, W 2 is also 0, W 3 is 0.2. Okay. Now, what you do it? My input value is this part, and how the weight will be set. This will be the last example for this one. Now, what you do it here? So, first you have to compute the y bar. Okay. Let us say this is fourth sample. Now, what you do? W 0 into 1 plus W 1 into x 1. See, if you note it, W 0, W 1, W 2 all are 0, plus W 2 x 2 plus W 3 x 3. So, this is 0, this is 0, this is also 0. So, therefore, only W 3 x 3. What is the value of x 3? X 3 is 1 and W 3 is minus 0.2. So, therefore, what we will get it, this value is minus 0.2 into 1, and that will give you the minus 0.2. It is negative, that means actually all, if you put sign, this is actually sign is there here, okay. Sign is here. So, you will get this value minus 1. So, therefore, error will be, this will be plus 1 because minus minus plus, and then y bar is also 1. So, then error will be plus 2, okay. So, and lambda will be 0.1, and let us say we are computing value for W 0. So, W 0 will be old value, W 0 old value is 0, 0 plus 0.1 into 2 into this one is always 1. So, how much it is coming? 0 plus 2, so 0.2. So, this will be 0.2. So, that is we are getting, no, we are not getting. So, in the fourth sample it should be 0. So, where is wrong? So, previous value was 0, that is okay. So, we got the value 0 here, plus lambda is 0.1, okay, and then this value is 1, and then what happened to this value? So, it is minus, means minus 1. So, minus minus plus 1, and what is the value of 1? 1. So, it should be 2. So, this should be 0.2. Acha, okay, just a minute. 1, 2, 3, 4, right, fourth sample. So, we are computing, this is forget 1, 1, 2, 3, I think we are right. So, we have to find what is the mistake. Let us try what is wrong here. So, W 0 is 0, W 1 is 0, W 2 is 0, W 3 is also, W 3 is 0.2. So, it is not minus actually. See, if you see here is plus 0.2. So, it is 0.2 only. So, it is not minus. So, it is a plus only. So, this should be plus. So, it is, if it is a plus means greater than 0. So, it should be 1. So, now error is what? Error y is 1 and this is also 1. So, this should be minus 1, that means it is 0. Okay. So, therefore, this will be, now I have to remove this part. Okay. So, now yeah, so this is 0. So, therefore, this W 0 will be 0, that is we see here. Similarly, for W 1, what will be the value of W 1? So, W 1 will be, W 1 is 0 plus lambda is 0.1, error is 0, and whatever the value at the end. So, W 1 also will be 0, W 2 also will be 0, and what about the W 3? Let us try with W 3. W 3 whatever the old value, so that will be assigned. So, okay, let us do it. Okay. So, let us, so what we do it here for W 3. So, W 3 is old value, that is 0.2 plus this part, right. So, So, this part is nothing but this is 0 means rest of the part will be 0. So, W 3 is 0. So, similarly this way we need to compute the all values here, okay, and this is for the single epoch, that means only one iteration. So, this is the final value after one iteration, and then similarly you go for the second iteration, third iteration, fourth iteration, fifth iteration, and after sixth iteration you see there is a little change of the value, and maybe you can accept it. Okay. So, maybe we can stop at this point. Next class we will see is single perceptron is not really good for identifying the little complex data where they are not linearly separable. So, therefore, is something called is the XOR problem. This is a very simple data as you can see, but there is no single perceptron that can identify the what is called is this classifier.